What's up, guys? Today, I'm going to be explaining science concept, Newton's three laws to you. So, firstly, let's check out the first law. The first law is pretty simple. It says an object, say a ball, like this, in motion simply means it is moving a distance in some time. So, I'm sure you know what motion means. It's just moving. An object in motion will stay in that motion unless another force is acting on it. If this ball is moving this way, it's going to keep moving that way until something else touches it. Now you may be wondering, hold up, when I roll a ball on the ground, it doesn't roll forever, it slows down. Well, so that means there must be some kind of force acting here that's slowing the ball down, because Newton's first law says that it should keep moving if there's no other force. So this force is actually when the ball rubs on the ground is actually, we call this force friction, and it's actually slowing the ball down, giving a small arrow this way. We define force with arrows, like we imply force and motion by arrows. So the ball's motion is in this direction, and there's a very small friction arrow. You'll notice the friction arrow is very small. If we made friction big, like this, it would mean that the ball would basically stop immediately. But that doesn't happen, so our friction arrow is small. So that's pretty simple. An object in motion will stay in motion unless acted upon by another force. Pretty simple. Using a new pen, we'll go over Newton's second law. This one you'll see pretty commonly as force equals mass times acceleration. But what does this mean? Well, let's rearrange it a little. We divide both sides by m. You get acceleration equals force divided by mass. So what this basically means is the amount an object accelerates. If you don't know what acceleration means, it means the rate of change of speed. How fast something changes. When something accelerates, like 10 meters per second squared, it means every second it's moving an additional 10 meters. So with an acceleration of 10 meters per second squared, in the first second, you're moving 10 meters per second. In the second second, you're moving 20 meters. You're slowly getting faster. So what this basically means is the amount of force you give, how hard you push it, your acceleration is equal to how hard you push it divided by its mass. So say you have a constant force. You can only push with forces measured in newtons. So you can only push with 10 newtons, and a newton is denoted by n. So if you're pushing with 10 newtons, this is very obvious in real life. When you're pushing with 10 newtons of force, and you're pushing one of those exercise yoga balls, it's pretty light. It doesn't have that much mass, which means the acceleration is more. It gets faster, much faster. It's pretty easy to get it rolling. But say you're trying to push a car. If you're trying to push a car, that's a lot of mass. Your force is getting divided by a lot. Your acceleration isn't that much. It's harder to start it to get moving. So going back to force equals mass times acceleration, the amount of force you give is equivalent to the amount the thing you're pushing accelerates multiplied by its mass. Sometimes this is called the law of inertia because it also says that objects don't really like to stop doing something once it's already doing it. For example, if you push, we did an experiment back in school, but say you put some guy in a chair. Starting the chair to get moving, getting the chair to move, is pretty hard. But once it's moving, it's pretty easy, right? Because since when you're pushing, your acceleration is actually, like when you're trying to get him to go faster, your acceleration is a bit more, but the mass is the same. So what does that mean? You need more force. But to get him to keep going the same speed, all you need to do is fight the force of friction. So your acceleration goes down to like whatever counteracts friction, which means you need less force if the mass time stays the same. You need less force to move the same amount of mass. It can be a little confusing, but once you grasp these concepts, it's pretty easy to understand. Basically, what it's saying is stuff that, like, if it's doing something, it doesn't really want to stop. Inertia is something's tendency to keep doing what it's doing. Right? Moving on to his third law, this one's also pretty simple. Every action has an equal and opposite reaction. When I say, that's me. Yes, incredible drawing. When I punch a wall, it punches me back. That's what it means. If the wall doesn't break, it punches me back. That's why my arm doesn't go straight through the wall. See, if we didn't have this law, so my arm's giving in force in this direction, this thing is giving the same force in this direction. That's what that's saying. So, if I punch the wall, it's giving an equal amount of force back to me, which is balancing out that force, so I don't go flying through that wall. We call this force normal force. Right now I'm experiencing normal force as I stand on the floor. Gravity is pulling me down, the floor is pushing me up. That's why I'm not melting to the floor. So that one's also pretty simple. Every action has an equal and opposite reaction. What's the reaction when I'm hitting the air? Well, here, it's actually still giving you an equal and opposite reaction. You have to think very carefully here. You're punching air, so it actually can't give back as much. When you punch a wall, we say it has a lot of normal force because you can hit it really hard, probably won't break. So it has a lot of normal force. Air doesn't really have normal force. So what's stopping you from flying? That's just your body's like weight, and when you punch, you'll notice something else probably goes back. Like maybe this shoulder, when I punch, that shoulder's going back. It's pulling me backwards. My weight's keeping me in one place. So that's what's happening when you're punching air. So yeah, that's it. That's Newton's laws. So I'll write them out for you here. So we'll go over them. Law 1, an object in motion will not change speed or direction unless there is another force. The second one can be summarized as F equals mass times acceleration. Right? Force equals mass times acceleration. You can rearrange it. Acceleration equals force divided by mass. And mass also equals acceleration divided by force. And 3, every action has an equal and opposite reaction. Right, so I hope this video helped you understand Newton's laws. If you have any questions, feel free to write in the comments, suggestions, write in the comments. If you like the video, consider liking and subscribing. Yeah, I'll see you in the next one. Thanks. Bye.